Hi, today we're going to do chapter 1, which focuses on atomic structure. We're going to look at the atom and how it is subdivided, as well as how to tell some important numbers in that atom. More specifically, I'll do section 1 of chapter 1 today. Section 1, as you can see here, is elements and atoms. Sections 2 and 3 will be separate videos. Section 1 is going to focus on the elements and the atoms of those elements. And we're going to look at just what the general makeup is of those elements and how do they differ. Elements are made of atoms. So this is an important distinction that needs to be made between the two words. Elements are a substance that cannot be broken down further into simpler substances by chemical means. There's 118 elements currently on the periodic table. The smallest part of an element that can undergo a chemical change is called the atom. So an atom is what makes up an element. So for example, gold is an element, right? And we can have a gold necklace or a gold ring. Those things are going to be made out of that element. So if we have a ring that's made out of gold, that's the element gold. If we have a necklace that's made out of gold, again, that's going to be the element gold. But within this element, within this material, if we were to zoom in really far, we will see a bunch of small atoms of gold that make up the element. So while the element is, again, the substance that cannot be broken down further into simpler substances by chemical means, and this is very important because it can be broken down by nuclear means, but it cannot be broken down by chemical means. That is our element. However, we can have a lot of that element, and that element will be made out of these little atoms of that element. Now, elements have their own chemical symbols that we are often going to see in our periodic table and in chemical reactions, in compounds, in all the things. For example, the chemical symbol for carbon is C, the chemical symbol for lithium is Li, iron is Fe, potassium is K. Some of these come from the English name, like C for carbon. Some of them come from either Latin, Greek, or even sometimes Cyrillic or German. Lithium is Li, but it's actually after the Greek name for lithium, which is lithos. Iron is Fe because I was taken by iodine. And so they went with ferrum, which is the Latin name for iron. Potassium, on the other hand, which has the symbol K, comes from either the Arabic or the Latin, and forgive me if I butcher these names, alkalia or kalium in Latin. That's why potassium has the K as its symbol. Elements are usually found in combination with other elements in compounds. A lot of the time, elements are not pure in nature. For example, a lot of the heavier elements like uranium are not just going to be found as uranium, but things like uranium oxides, like rocks and minerals. Some of them, however, are found as pure elements. Most notably, the noble gases, which we learned about last year, are found in their pure element state. Noble gases such as helium, argon, xenon are going to be found in their natural state in nature because that's how they're most stable. We'll talk about the stability of these elements later in the year. But this is just a brief overview of elements and the difference between elements and atoms. We'll keep talking about elements and atoms in section 2 in the next video.